Alright, this is the in-class practice worksheet, and it's the one that says AA and SSS. And then we had a request to do number 4 and number 5. Now the key to doing these is just to draw the triangles. They tell you in triangle QRS, so I'm going to label it. They tell me that QR is 10. You have to draw and label. It's not going to come out of heaven and hit you on the head or anything. You've got to draw and label. That's how you solve these. SQ is 12. Then they tell you in triangle UVT, and we're kind of guessing that if they went QRS, you're going to go UVT. So go ahead and try seeing if they match up. They tell us VT is 20, and they tell us TU is 24, and they tell us UV is 24. Are the triangles similar? Well, if they're similar, then all of these fractions need to be the same. I need to divide 10 and 24 and see what it divides out to. Then I need to divide 12 and 24 and see if it divides out to the same thing. And actually I can stop right here because 12 over 24 is a half. A half. 10 over 24 is not a half. 2 would go in there 5 times. 2 would go in there 12 times. So since these ratios are not the same, basically what we have here is we do not have the same scale factor, because I could figure out the scale factor, or at least the ratio, what it reduces to. They should be the same between all these sides. I also could have tried 11 over 20, but that's not going to reduce to a half either. So they don't have the same scale factor, so not similar. So that's all you have to do is match up sides and divide those fractions out and see what you get. 5, same thing. You draw the triangle. You can't do anything without drawing the triangle and labeling it, so don't even try. And we're going to guess that TUS is also, they want to know if these two triangles are similar. So if they're similar, they're going to match up in this same order if they work. So let's see, PQ is 10, QR is 13, RP is 11. Remember to just pause the video if you need to write some things down. US is 40, ST is 52, and TU is 44. So if these are similar, all these fractions are going to divide out to the same thing. So I'm going to do this. I'm going to put 10 over 44. You know what? I'm just going to do one at a time. That way if I run into two that don't match, I can stop because I don't want to do more work than I have to. You could divide this out and get a decimal if you wanted to. That's 0.22727, and it repeats, okay? So it's repeating 0.227, and this part repeats. Now let me use a different color to match up another set, 13 and 40. If I divide 13 over 40, if I don't get this same number, then I can stop because I'll know they're not similar. I need to get the same number for them to be similar. 13 divided by 40 is 0.325, so they are not similar because these two fractions are not dividing out to the same number. And that's all there is to those two. Okay, so this is a similar triangles page on the back, numbers 22 through 28, these statements, and people had trouble with them, so I'm adding them to the end of this video. Two equilateral triangles are always similar, and the reason is because equilateral triangles will always have all the angles are 60, 60, 60, and that's when I can say by angle, these are similar because the angles are all congruent. Now on 23, if I have two similar triangles, let's say this is 3, 4, 5. That would be similar to something that was multiplied by a scale factor of 2, for instance, 6, 8, 10. Those are not congruent. They're similar, but they're not congruent. So you could say they are sometimes, you know, if you have the same triangle twice, they would sometimes be congruent, but not always. Most of the time, two similar triangles are not going to be congruent just because they're blown up by some scale factor by definition. Okay, so now let's look at number 24. Two congruent triangles are always similar. The thing about congruent triangles is they're going to have angles that are congruent. And if you've got all the angles congruent, then those will also be similar. Okay, so let's look at this one. Two isosceles right triangles. Well, an isosceles right triangle would have a right angle in it, right, correct? And if you have two other angles, they're going to be congruent because it's an isosceles triangle. So 180 minus 90 would leave you with 90 degrees to split two equal ways, and that would be 45 degrees. So this would be 45, and this would be 45. And even if the sides are bigger, you're still going to have 45 and 45 because this one's also isosceles. Since the angles match up and are congruent, then they're always going to be similar. So we're going to put always there. And again, it has to come down to the fact that your angles are always going to be congruent. On 26, two squares are blank similar. Two squares are always going to be similar. Think about their angles, because really similar, you can prove two figures are similar just if their angles are always congruent. So let's say I have a big one and a little one. Well, they've all got 90-degree angles. Excuse me. So since their matching or corresponding angles are congruent, they're always going to be similar. They're not congruent always, but they're similar always. Okay, number 27, two isosceles triangles are sometimes similar. Most often they're not going to be. For instance, I could have an isosceles triangle that has 40 and 40 here, and then in this angle up here would be 180 minus 80, so this angle up here would be 100 degrees. I could have another isosceles triangle that has like 50 and 50 here. That would add up to 100, so 180 minus 100 would be 80 up here. These are both isosceles triangles, but they're not similar because their angles don't match up. So that would just be a sometimes. And let's look at 28. Two right triangles are blank similar. Most of the time, they're not going to be similar. Sometimes they are. They're only similar if their angles match up. So if I happen to have a 30, 60, 90 maybe, and a bigger 30, 60, 90, those would be similar. But couldn't I have a right triangle that was 30, 60, 90, and another one that was 45, 45, 90? Those angles don't match up, so they're not similar. So sometimes I can find them, and they'd be similar, but most of the times they're probably not going to be, and you just never know till you look at the angles and see if they match up.